Hello, today we're going to be adding and subtracting signed fractions. So there are some steps we can take to help us make sure that we are doing this correctly. And by signed fractions, we mean they could be positive or negative. If I'm given mixed numbers, I need to change those mixed numbers into improper fractions. I have shown you a way in the past where I can keep them as whole numbers and their fractions. Makes it a little bit more difficult when you've got the negatives involved because those can get kind of confusing and get kind of mixed up or get lost. You need to be careful with that. Sometimes it's just easier to turn them into improper fractions. So for instance, down here I've got 1.5. I want to turn that into an improper fraction. In other words, I'm looking for another way to show it that makes it just a fraction. So what I've been telling my kids, if you think of 1.5, there's cute little tricks, but just to make sure we understand where this comes from. If I had one whole candy bar and I cut it in half, I would have 1/2 and then I would have 2/2. So that would account for the whole. I then had another half of a candy bar, and knowing me, I must have already eaten the other half. So I have 1, 2, 3 halves. So I can write 1.5 as 3/2. Now the cute way to do that I'm sure that they were taught, makes it quick and easy, is I take the whole number and I multiply by the denominator and then I add the numerator. So 1 times 2 is 2 plus 1 is 3, and then I keep the denominator. But I want to make sure that you understand the why of how that happens. Now from my original problem, I also had a -3/4. Now this is already an addition problem, so I'm not going to need to change it. What I am going to have to do is I'm going to have to find a common denominator, and then I'm going to add or subtract here in just a second. But first let's find that common denominator. So if I have -3/4 plus 3/2, I always ask myself, I start out by saying, is there something I can multiply 2 by to get to 4? Well, I can go 2 times 2, that will get me to 4, and whenever I do the bottom of my fraction, I have to do to the top. So now I have -3/4 plus 2 times 2 is 4, and 3 times 2 is 6. Now that I have the same denominator, I'm going to add or subtract the numerators, following the rules that we have set up for integers. So I've got a -3 plus 6, which is 3. And I always tell my kids they can cover up the numerators and they know that problem and how to do that. Keep the 4, and my answer is 3/4. Because once I find that common denominator, once I split it into those same size pieces, I don't want to change those size pieces. I did that for a reason. I need to be able to group them together. My next problem here, I have another mixed number. So again, I'm going to think, oh, if I had 2 whole candy bars and I cut them into 8 pieces each, that's 16 pieces. That's why we do the 2 times 16. And then I had another 5, so that becomes 21/8. I then had subtract 2/5. Well, when I see subtraction, I change it to addition because I have some really easy rules to use for addition. So I'm going to keep the first number the same. I'm going to change that subtraction to addition. And then I need the opposite of that number. And since it was negative, it becomes positive. So now I have 21/8 plus 2/5. Now that I'm ready to add, they're both positive. I just need to find a common denominator. One easy way to do that, if 5 times something doesn't get me to 8, is I can just multiply the 2 denominators by each other and get 40 as our new denominator. Now remember, whatever I did to the denominator in that fraction, I need to do to the numerator. Then I'm going to add, keeping that denominator, Now I have an improper fraction as my answer. I need to turn that back into a mixed number. You might be able to sit here and just count by 40s and see how many you can get. You could also do this as a long division problem. So you could do 121, it's always the numerator, divided by the denominator. And I can see that goes in 3 times. I have 1 left over, and I cannot make another group of 40. So 3 and 1/40. Our next one here is -3 1/2 minus 4/7. Now the big thing I see my kids do is when they turn this into an improper fraction, they lose the negative sign. Don't lose your negative signs. Make sure you're very careful about that. So remember, it's the whole number times the denominator plus the numerator. So 3 times 2 is 6. 6 plus 1 is 7. So I have -7/2. Don't lose that negative. And then I'm subtracting 4/7. I'm just going to bring that up over here now that they're fractions. And I see that it is subtraction, so I'm going to do keep, add, the opposite. So subtracting a positive, remember, is the same thing as adding a negative. So now that I know what I'm doing, they're both negative, I know my answer is eventually going to be a negative answer, and I know I'm going to add those two numerators, but first I have to find a common denominator. So once again, I'm going to multiply them times each other. Seven times 7 is 49. Remember, that was negative, so this also needs to be negative. And 4 times 2 is 8. Once again, it was negative, so it's still a negative plus a negative. My denominator is going to stay the 14. Negative 49 plus negative 8 gives me negative 57. And I'm going to have to figure out that is going to be a mixed number. Once again, do not lose the negative. That is crucial. How many 14s can I get in there? Will Stewart today figured out for me that it was 4. And I have 1 left over, so its answer to this problem is -4 and 1/14. Our next question here, 2/3 plus -9/10. They're already fractions. I don't have to do the whole mixed number into a fraction. I need to find a common denominator. And once again, do not lose that negative sign. So I'm going to look at these. I'm going to blow them up over here so they're a little easier to see. I'm going to go ahead and multiply. So I'm going to get 20/30 plus a negative, don't lose that negative, 27/30. I'm going to keep that denominator. Now I have positive 20 plus a negative 27. Remember, you can cover up those denominators and look at that problem. Different signs, so I'm going to subtract. So 27 minus 20 is 7. I have more negatives than positives. My answer is -7/30. My last one here, I'm going to have to change that. So I'm going to multiply and then add. So 3 times 12 is 36 plus 1 is 37. So now I have 37/12. So I have 5/6 minus 37/12. I'm going to keep and add the opposite. So remember, these are parentheses that just separate. They are not absolute value bars. Can I multiply 6 times something and get to 12? I sure can. So I am going to multiply this times 2 and this times 2. So I'm going to get 10/12 plus a -37/12. -37, positive 10, I'm going to subtract. And I get -27. Remember, don't lose that negative here when we turn this back into a mixed number. If I have 27, how many 12s can I get? Well, I can get 2, and I have 3 left over. This particular problem, 3 12ths can be reduced. Once again, don't lose that negative to -2 1/4. There are extra practice problems on the back of this page. And the nice thing about these practice problems is that there is an answer bank at the bottom. This is attached to the weekly agenda, so if you need it, you can get it and print a copy out and do some practice problems. But there are some more practice problems on the back if you need them.